again. So thanks everyone for being here. My name is Sunny Liu. I direct research at Stanford Tech Impact Policy Center. So today we had a lot of fun for the first 10 minutes because of some conflict. So we tried all the different modes of communication, and from phones to text messages and to Zooms, and we tested Stanford Wi-Fi's. Turned out Stanford Wi-Fi is not the fastest in the world. But today we're super excited to have Pete Norvig to join us. I don't think that Pete needs any introductions, but I still want to do that. So it is really my greatest pleasure to introduce our distinguished speaker today, Dr. Pete Norvig. Pete Norvig is a distinguished education fellow at Stanford.
Hello, everybody. This is
at Stanford Institute for HAI and Director of Research at Google. He might be the most influential figures in AI. So it's really the true pioneer that contribute to shape AI's history, current, and the future for decades. His book, Artificial Intelligence, a Modern Approach, is
recording in progress.
Yeah, is a Bible in the field. I think all those 3 decades of engineers, students, and practitioners use that way to think and shape and build AI systems. I also really want to always jealous about Pete. Not only because I think that his visions, but also I spend lots of time myself to maybe too much time on Sudokus, and each of those ones I found super challenging. But Pete and write 1-page code and pretty much can solve any Sudoku levels. I'm very jealous of that. So today we're super excited to have Pete because he will talk about one of the main challenges and the most important, I think, topics and domains, education. Decades, and I think that through human histories, we always want to make it work. But it seems that we haven't not figured out that yet. So I cannot wait to see, Pete, your visions and perspectives on AI and education. So please join me to welcome Pete. And Pete, the floor is yours.
Thank you for that kind introduction, Sony, and my apologies to everybody present for not being there in person and for being a little bit late to connect. I had a little family health emergency this morning that we had to deal with, but it looks like everything's okay now. So let me share. Okay. Does that look okay? If you see it now? So I want to talk about the present of AI in education, but I want to go back into the past first. So here's a woodcutting from the 14th century, University of Bologna, world's first university. And here you see a classroom, and you see a lecturer on the stage. You see a textbook, as Sony mentioned, we're familiar with that. And you see the sleeping guy in the back of the room. We haven't really come very far since this 14th century. We still have this kind of outmoded way of transferring information. We're going too fast for half the class, too slow for half the class, and part of the class is completely bored. In 2011, my colleague Sebastian Thrun and I said, maybe there's a better way. Instead of just lecturing to a small number of students at a time, maybe we can have something that reaches more students and in a more personalized way. So we built an online class offered through Stanford. The subject happened to be AI, but what was more important was sort of using technology to deliver that class. Of course, in 2011, the main technology was just YouTube, not as advanced as what we have now. Now, one of the most important papers in the history of the learning sciences is by Benjamin Bloom in 1984. And he said the most important thing is one-on-one tutoring and mastery learning. And here's his little graph. You can see it's outdated because it was done with a typewriter. And he says, here's this bell curve. If you add mastery learning, you get 1 standard deviation up. And if you add one-on-one tutorials, you get 2 standard deviations up. Now, when people tried to replicate this, they get about half a standard deviation, not 2 standard deviations. So he was a little bit overzealous there. But it is clear that the mass lecturing is not as good as tutoring and not as good as this idea of mastery learning, is that you should keep learning until you get it, rather than saying, okay, you got a C on your test, too bad. Tomorrow we're going to do something that's twice as hard and you're going to fall farther behind, which is what we mostly do today. Now, one of my idols, one of the founders of the fields of AI, Herb Simon, said learning results from what the student does and thinks, and only from what the student does and thinks. The teacher can advance learning only by influencing the student to learn, and I believe in that. I also believe in Teddy Roosevelt saying nobody cares how much you know unless they know how much you care. And so having that personal connection seems important. Here's a picture of me with my first teacher, my mom, and that personal connection, I think, was really important to what we could do. And here's this transformation into me delivering a lecture with a camera overhead for this online class. Now, Sebastian and I did this class through Udacity. At the same time, Daphne Kohler and Andrew Ng were doing a class through Coursera, and all 4 of us are sort of experts in machine learning. And I think that's no coincidence, because I think we all felt if we gather more data, we can do a better job of making learning better. I wrote the paper on this topic, and if we had more information about what a student's doing, we should be able to do better. And we showed that we could. So we had this sort of reinforcement learning approach. You show a student a video, you ask them a question, depending on how they respond, you figure out what should you do next? Should I show them another video? Should I ask them another question? What should I do? We can do that, and we can make the students about 10% better by applying machine learning to this issue. But we wanted to make them 100% better, not 10% better. And that was the best we could do in 2011, but this is 2024. And working at Google with the Gemini team, there's this motto of a tutor for every learner and a teaching assistant for every teacher. I think the mixed initiative is really important. So with the MOOC, it was like the system was in charge and you could just answer one question and then you were back on the same track. With the large language model, there's an empty box and you can ask anything you want, but you don't know what to ask. And I think I want something in between where part of the time the teacher's in charge and part of the time the student is saying, here's what I'm interested in. Now, I want to talk about the difference between traditional software and AI. And I think the main difference is with AI, it's the open world problem. We can do anything. And here's an example. A while ago, I got this pop-up that says return rental car to Logan Airport. That was great. It's got the map, did it at the right time. And then it spoils it all by saying time of travel, 23 minutes by bicycle. Now, why did it say that? Well, because I commute to work every day and it's about that distance. But it did not understand what it meant to return a rental car. And as a Google employee, I said, maybe I should file a bug report. But then there's this little drop down that says, whose fault is it? And it turns out, I don't think anybody's really at fault. This is not the type of problem that you can solve with traditional software unless you want to say, I want to describe everything about the world, about how rental cars work and everything else. But can AI do it? Well, in 2023, they couldn't. I go to a large language model, ChatGPT, and ask, should I return rental car to the airport? Should I go by bicycle? And it says, it depends on several factors because it's been overtrained for safety. And so it says, whenever a question about bicycle comes up, I should warn you to be safe. In 2024, now they finally get it. And you ask and it says, no, you should not go by bicycle. So for the first time, we have these systems that sort of by default know everything or a large portion of what there is to know about the real world. And that's a basis for building a teaching system on top of it. It's the first time it could happen. It's really just in the last year. Now, I think mankind's greatest technology is the written language. Spoken language was great too, the fire, the wheel, all that stuff. But in some sense, written technology is what allows us to have our civilization and our knowledge pass from one generation to the next. And I've been in this field of trying to understand written language with a computer since the 1980s. And I always thought there's some stuff for words on the page. And as computational linguists, we can figure that out, all the noun phrases and verb phrases and so on. But the hard part, I thought, is not what's going on the page, but what's going on in the head. And we tried to program that into a computer, and it was hard. Now, the new approach is, can we do that with a computer? Can we have it read pages? What do we put into the computer? For decades, we tried to program that in by hand, but now we just do it with a large language model, and it just learns by itself. And in 2024, yes, this works. And we have places like Conmigo that are using a language model as an AI tutor, and they specially train it to not give the answers away, to be helpful, but to make the student learn. So it's a question of quality and creativity. So here's a question. My friend showed me this problem. List all the ways in which 3 distinct positive integers have a product of 108. And it gave it to this language model, and it made a mistake. It left some out. Now, I took the same thing, and I said, can you write a function to do that? And it did it, and it worked. Now, why did writing a function help? Why did the language of programming help? And I think the problem is, so it started out here, and it came up with the right approach of saying, I want to factor 108 into its prime factors. But then it kind of forgot that 1 is also a factor, because the way you write prime factors in math, you kind of leave out the 1. And so it forgot answers that had a 1 in it. But when you're writing a program, you write a loop that says for I equals 1 to n, you don't say for I equals 2 to n. It's just sort of the conventions of how math works versus the convention of how programs work. And I think the lesson to take away here is there are many ways to think about things. And sometimes the language of English is the best way, sometimes the language of math, sometimes the language of programming language, sometimes the language of chemistry equations, and so on. And so we want a system that could deal with all of them. And this idea of having the right representation seems really crucial. And so this schematic diagram here says there's stuff going on in the world. We can never understand all of that. Fortunately, a lot of it is written down. So that's sort of compressing what's known about to the world, hopefully to the good stuff. And then we compress it further into the few billion parameters in our model. And then a question comes in. And one move you can make is to say, I'm going to represent this using a program because that's a good representation. I can run the program to figure out if I got the right answer or not. And I can come up with the best representations to come up with the answer. Here's a question of understanding novel problems. This was a brain teaser of here's some possible birthdays, and you're trying to figure out what the birthday is, and you're said, Albert says, I don't know, and Bernard says, at first I don't know, but now I know, and then Albert says, okay, then now I know. And the reason I chose this as an interesting problem is because there's been a lot of talk about, do large language models have a theory of mind, a theory of what other people are thinking of? And I knew that there were logic problems like this that where knowing what other people were thinking about was really important. And so I tried this on 9 large language models, and they all failed. They didn't use a theory of mind. And so I thought that was interesting, that we've come to some phase where some stuff works and others doesn't. So this was one of the first large-scale coding problems that worked. This is AlphaCode from 2022, I think. And this was a primary example that showed, and it gets the program right. I won't go into the details, but as a code reviewer, here's all the things that were wrong with it. So it's sort of like every other line, there was something that was not quite right. And I call this the Lake Wobegon effect, that these systems are trained and half the training data is from programmers that are below average. So maybe it's okay that they came out below average. But that was in 2022, 23, 24. In November and December of 2025, all the systems came out with new models, and they improved rapidly. They're really at the level now of an expert programmer. And so we have this capability that's increasing month by month and year by year. And I see a lot of people say, no, we can't use computers for education. And when I say, when was the last time you checked? If they say it was more than a year ago, I say, you've got to rethink that opinion. Things are changing quickly. And we've seen silver medal and gold medals in the Math Olympiads problems. I won't go into the details there, but just want to talk a bit about pedagogy. This idea that systems get better with chain of thought prompting. So we ask the system, what's the answer to this problem? It may get it wrong. If we say, show your work, it's more likely to get it right. And that's helpful for just getting the right answer, but it's also helpful in teaching. At Google, we have this Learn LM initiative, and the principles we're trying to uphold are to inspire active learning, to manage the cognitive load, to figure out what's the right thing to say and what's the right thing to not say, to deepen metacognition, to make the student think, say, okay, you got the right answer, but what's another way to think about that? Simulate curiosity, to figure out what is the student actually interested in. We don't want the sleeping guy in the back of the room. We want to know what's right for this student and to adapt to them. Now, one of the things that also has happened in the last year that I think is just fascinating is the possibility to have models of students and simulate them. Now, I've done some work in self-driving cars, and we have this slogan that the first million miles are the hardest. So you got to drive your car for 1,000,000 miles on the road, and then you can build a pretty reliable simulation, and then you can start driving billions of miles in simulation. So that's what really makes the big difference. Now, with education, up to now, we haven't had that at all. We don't have anything where you can simulate a student. So when Sebastian and I were running our class, we got data from students, and we were really good at saying, if we want you to solve this one problem in the next minute, what should we do to make you better? And as I said, we can make you 10% better. But if we wanted to ask the question, if we want you to be an accomplished person in this subject a year from now, we got to gather data for a year. And if we made a mistake, we got to gather another year's worth of data. So without simulation, progress is limited. And it does seem now, there's been these experiments by economists and others where they tell LLMs to take on a persona, ask them a question, and the results they get back are similar to what actual people would answer. So maybe there is this possibility to do simulations, and I won't go into the details of how it all worked. Now, one of the big questions we get from the use of AI is, aren't students just using it for cheating? That these AI systems can write a good essay, they can write a good computer program, they can pass most of the tests that people give. Chris Beach, my colleague here at Stanford, says LLM solve 100% of the exercises for his class. So the question is, what do we want from that? Let me skip this and say, we're at this point now where maybe we want philosophers to be answering our questions rather than technologists. Here I have this noted philosopher, Professor Jagger, and the question seemed to be not so much what programs do we want to build, is what is it that we want to optimize? We have these systems that you can train them to do anything you want, but we want to know what is it that we want. And so his answer is, you can't always get what you want, but you get what you need. But I think Professor Jagger's got this one backwards, because we've got an amazing system that we built to give you what you want. Every time you click on a link or watch a video online, you get more of that. And I'm sorry, when I do it, you get more of the junk that I clicked on too, because of the collaborative filtering and recommendations. But we don't have a system to give us what we need. I think we really need better ways of saying, what is it that we want and how are we going to get there? So we're no longer programming the computer step by step to say, do A, do B, do C. Rather, we're saying, we want you to achieve a goal. We're going to give you a lot of data. The neural net will automatically optimize that. But we don't have good ways of saying, what is it that we need? And that's true in society as a whole. And it's certainly true in education. What are the important parts of education? It can't just be writing this essay and getting an A on it. It's got to be something deeper than that. And we don't have good ways of measuring that. So the problem is that imperfect decisions have trade-offs. So 200 years ago, Judge Blackstone says it's better that 10 guilty persons escape than that one innocent suffer. I'm not sure if he meant that literally, 10's worse, 11 would be okay. So he didn't quite have a formula there, but he knew we wanted to balance it one way or another. And I think we have to ask these questions of what is education for? We can't optimize it until we know what we're trying to achieve. So there is an amount of general knowledge. There is an amount of specific knowledge or skills for profession. There is developing thinking and reasoning skills. There's motivating, inspiring people to do more. There's promoting civic and social coherence. And there's a question of what level are we focusing on? I focus mostly on college, but my colleagues focus on K-12. Lifelong learning seems important. It doesn't make any sense to me that you go to a school for 4 years and you get a piece of paper that says, I never have to learn anything again as long as I live. So let me stop there and open it up for discussion.
Thanks so much, Pete. I have so many questions because I think that all the points you touched are super interesting. So we'll try this one first time in this room as well. So because I have many questions, I'll first ask those questions and then we'll open to the people here. We have people running mics around. And for the Zoom audiences, I think today used to be that is, I think that Ben will send those to my phone, but I think today I think that we have amazing band, Michelle. So if the Zoom audiences, if you can, I will leave some time for you. So Michelle and I think that Ben can see those questions. And Pete, you can pick the questions you want to answer and ignore the ones that you don't want to really answer at all. So Pete, if that works for you, I will start with my questions. I was really struck with, I think, that your first slides. I think that in the 14th century, and the mode of education is we have instructor and people, students there, and seems not changed at all. I appreciate all those great efforts from mock and all those classes you do, but I think fundamentally the education is still the same. Why do you think that's the case? Is that we don't have fancy or not powerful technologies as AI, or it's really like the rooms all set up like this way, have podium and all those seats, or is that because all the education systems that teachers and students, all those power dynamics. So what do you think? What do you think that all those centuries we still hold the same, not very efficient way of teaching and educating?
Yeah, I think it's a limitation of the people power that we have, right? So I skipped an earlier slide. I went back to the 14th century. I could have gone back farther to Socrates and shown a picture of Socrates talking one-on-one with a student, right? So that would have been a much better experience. But there are only so many Socrates that are available. And I think, we've done a good job as a society of saying we want to expand access to education. We don't want just the few lucky, wealthy few to be educated. We want more people to be educated. And so like in so many other industries, we said, we're going to have to figure out a way to kind of mass produce education. And so it can't be, I'm sitting down with Socrates under a tree discussing knowledge. It's got to be some way that's more effective, where one teacher is reaching many students at the same time, and I think we came up with the only way to do that. It's sort of this classroom-oriented approach. Uh, but now it feels like the last couple of years, for the first time, we have these language models that can perform some of the functions of a human tutor. And, they're not there 100% of the way in terms of what they know and the mistakes they make, the jaggedness of they're great at some things and then they can be terrible the next, and also in terms of having the human connection. So I think of them as tools to say, here's how we're going to make the teacher better. Uh, and we'd already been going in some of that direction, right? So even before uh, AI models, we had this notion of a flipped classroom had been used quite a bit of saying, I want all the students to watch this video that I pre-recorded ahead of time, and then during the class period, we're going to have discussion and interaction and maybe one-on-one where I'll go around and talk to the students who need special help while the other students are working on something else, rather than the lecturing approach. So I think we've been going in that direction for a while, and the AI tools now make it all that much easier, and therefore it seems like this is the first time that it's happening, where it's actually been happening for a while.
Amazing. I have two follow-up questions. I will start with the first one. So I think I really agree with you. I think that it's really the resources have. I think at Stanford, I think one of the best and most beautiful campuses, we have those, a student can sit with Pete under a tree or at a Cooper Cafe and have those conversations, best learning experiences. Before I come to Stanford, I taught at Cal State for 7 years. So those populations are very different. Most students are full-time. They're first-generation college students. They don't even know how to lock the door for professor. And they have their full-time jobs. They also have full-time students. They have their family to support. Sometimes sad is, so they did lots of sacrifice to go to those classes. They worked at Walmart or Target during their schools, and after they graduate, they still can only get a job at Walmart and Target. Are there even possible so we can have those power of AI or those Stanford ways to other colleges? If so, how? And what's your vision there?
Yeah, so that's interesting. And I mean, I guess one overall question is what's the future of universities as a whole? Uh, Second is, I think it does make it easier to say we can get quality education to more people. So I felt like I was doing my small part in doing that by writing textbooks, by saying, you know, here's the way we teach people at Stanford and Berkeley. I'm going to try to write that down so that this can be ported to any university. And to some extent, that works pretty well. I think there is a question of is the university the right way to do it, and is taking 4 years off and being a student full time the right way to do it? And you mentioned people who maybe it's very hard for them to follow that mode, that they're working part time just to get by. Maybe we should make that more of the norm, and college could be spread out over a longer period, maybe shorter certifications of specific skills and so on, so that people can be kind of make it more the norm that they're join the workforce earlier but continue to be educated for longer. That might be a better approach. And then I guess another thing that I think is really fascinating to me is the capability of more people to be creative in what they do. And I think we've seen a shift in that over the decades. If you go back 50 years, it was kind of expected well, you'd get one job and you'd stay with one company for a long time, maybe your whole career, or at least for many years. And now it's much more expected to shift jobs more often. And there's a lot more emphasis on being your own boss, starting your own company. And part of that is because it's much easier to do now. You need less capital, right? So if I wanted to start my own computer company, I wouldn't need to buy big expensive computers and a big fancy office building, all I need is a laptop and a Starbucks card and I'm started. Uh, so that's possible. You also see things like, in one sense, it's maddening to me that being a social media influencer is one of the most sought after jobs for young people today. Uh, but in another sense, I think it's great that they're saying, I want to run my own business and I want to work for myself and I want to be creative in coming up with something that nobody else is offering. So those, I think, are encouraging signs.
Love those ideas. Peter, I love this. I think that be creative and then leverage AIs to advance their careers. So at Stanford, we have large projects related to AI literacy. So what we did is, I think Fangjin is leading here. So we asked a small army of undergraduate RAs to take all those AI literacy classes ever offered without a paywall. So we have those students spend hours doing those classes for about 6 months. And after that, I said, wow, you spend so much time, you must be experts. All of them tell me, no, I'm not. So I think that they say it's really there's gaps between know what is AI is and then understand fundamentally, but they still don't feel they can use AI in a way to grasp those benefits. So what's missing there? Do you think that is a current structure, those AI literacy class bad designed, or it's the way they take class different? How everybody can do that to really realize what your vision that they can be more creative using AIs? Yeah.
I guess my advice would be just go out and do something, right? So I could certainly sympathize with them saying they don't think they're experts. So, I feel like I'm behind, right? I feel like I can't keep up. Every week there's, too many new developments, new papers, new programs to try and so on. So I feel like I'm following farther and farther behind every week. Uh, and but I guess you want to get used to that, to the idea that you can't know everything, and just say I know enough to get something done, and just go ahead and try it. So in my class, CS 139, there's no prerequisites for the class, so we had a lot of CS majors and engineers, but we also had a significant portion of the class with no technical backgrounds. They were from the law school or from political science or from other fields that were interested in our class. The class was human-centered AI. So there was an AI component, but there was sort of human-centered policy component. And one of the things we said is, okay, in this class period, everyone is going to build an application of some kind using AI coding. And, for some people, it was like, oh yeah, I did one last week, so sure, I'll just zip one off right now, no problem. For other people, it was, oh, I've never tried to do anything like that before. This is scary. But every single person, 100%, got something working by the end of the class. So, I think some of it is just get over the fear of attempting and just start going out and doing something. And, when you do one thing, then you have confidence that you can do it again. And next time you do something a little bit more complex and that you build that confidence up.
Yeah, I love this advice. So we can all try. For me is I want to learn to build my own website for a while, so maybe I can try that. I heard that web coding is a really good tool. So Pete, my next question relates to this. I think that you mentioned you also feel like they're really hard to catch up. I remember your wisdom is, I think, learning something with 10 years.
Yeah.
Do you still feel that 10 years a reasonable time frame, or you think now it's like 5 years? And what's your advice for people to trying to be creative with AI? I want to follow up a little bit. We have an amazing undergraduate student here, and she thinks that there's a lot of pressure for hustle culture. You have to finish lots of things a lot of time at the same time. So what do you think? What's the best advice you can give us to about 200 people in this room and on the Zoom, and how to we really survive or feel not stressed by
Yeah.
those AIs?
Yeah, so you mentioned this essay I wrote a number of years back. It was a time when there were lots of books out of, teach yourself programming in 7 days or 24 hours or whatever. And in response to that, I wrote this essay, Teach Yourself Programming in 10 Years, saying to really achieve expertise in any complicated field, it is going to take you a long time. Maybe not necessarily 10 years, but some long period of time. And but I guess I'm sympathetic to both views. That yes, if you want to be an expert, it is going to take years of dedicated study and improvement. But if you just want to get something done, then there is a lot you can do in a day or a week to get some expertise in some area. And and I think it's really hard to get the right mix of that. And I see that even in my own work, and I do see kind of a generational shift, right? So I'll be at work and working with a younger colleague, and we'll say, "Oh, here's this new software package, and this seems like this is a great tool to solve this problem we've had." And so, I'll sit down and I'll start reading the manual for that package and trying to understand how it works. And then my colleague will come back in a few minutes later and say, "Okay, I'm done. Let's move on to the next thing." And I said, "What do you mean you're done?" And they say, "Well, I figured out you got to call this function and it returns this result, and that's what we need, so we're good." And I say, "But I don't understand how this whole package works. How does it do X, Y, and Z?" And they say, "Oh, I have no idea, but I figured out how to get it to do the right answer for this one thing we needed." And I feel like sometimes they're right. And it was a conceit on my part to say, I want to understand completely this big, complicated thing when I didn't need to understand it. It's like, I don't need to understand everything about the engine in my car in order to drive to the store. And so sometimes they were right, and I shouldn't have wasted that time. And sometimes I'm right. And if we don't understand at a deep level what's going on, it may come back to hurt us later. But I feel like neither of us made a principled choice, right? Sort of, I did what I was used to doing uh, from decades ago, and they did what they were used to doing, and it was different. And we have our approaches, but neither of us did a really careful, rational analysis of how deeply should we have gone into this. And so it's something I think about a lot now, and I try to do a better job of saying, is this just my inclination? What is the right amount of attention to pay to this versus pay to something else? And I think it's really hard to get that right.
Love it. I think we need lots of economists here to really design new games to calculate those utilities and the perfect decisions. Cool. So I have my last question. I have a lot of them, but I think that also where people have lots of questions in the room, and I already got a lot of questions on Zoom. So Peter, my last question is, so I talked to one of those, also another academia I admire a lot. And her comment struck me. She said that there's lots of noises now about AI. I never thought about that. Actually, people are just working so hard on this. So I'm just curious for you, who is really the leader and also the one finding this field, what do you think are the noises in this field? And what are something that you are most excited about in 2026? You think that the smartest people in this room and on Zoom should think about and maybe work on?
Yeah, so I think it's amazing how quickly things are moving. And you see advances all the time. I think our understanding is still lagging behind. And so, I would hope for the future that we do a better job of really understanding what works and what doesn't work, right? I think we built a system where, there's lots of knobs you can tweak, and you can try something, and if it makes it better, you do more of that. And so the systems get better every year and every month, but I don't feel like we have a really deep understanding of how it all works. I guess, so what am I excited about? I mentioned this really big jump in the ability of systems to program basically just in the last couple of months. So that's pretty exciting to me, both as a programmer, it solves some of my jobs, and also just as a medium of communication. I think this helps make the systems better, right? And I think there may be other ways of reaping some of those benefits for things that don't have to do with programming. So why is programming so great? So one of the things we've seen, especially over the last year, is language models that are a mixture of experts. And all that means is instead of just asking it for one answer, you give it the problem and it splits them up and it tries 10 different ways, and then it figures out some way to vote or aggregate the results and come up with an answer. And just as often, if you have a team of people working together, that works better than one person. Having a team of programs within the program working together, that often works better. But if the output was 10 different paragraphs, it's hard to compare them and say, how do we aggregate these 10 paragraphs and to get one good paragraph? Or can we get more reliability in these paragraphs? But if the answer is 10 different programs, then you can run the 10 programs. And if 9 out of 10 of them give the same answer, and now you have pretty good confidence that that's the right answer. And you can't do that with other forms. So I think using the language of programming, language of mathematics, and other languages where you can more easily verify the results, I think that will be very exciting. And then the capabilities to interact with other systems, right? So we call them these agentic systems that can go out and use other software tools. That's been developing quite a bit over the last year, and I think we'll see more of that. And we may see a future where your whole operating system, instead of being a bunch of apps that you press a button on your phone to connect to Uber or Domino's or whatever, there may just be one big app, which is my personal assistant. And I think that will be great because it'll give me more confidence, right? So right now, when I press the button for Uber or Domino's, I say, well, they want me as a customer, and so they want to do a good job for me. But I also feel like, they want to make a profit for themselves, number one, and I'm only number two on the priority list. But if instead we had a system where I felt like, I've got my personal agent and I trust that it's on my side, and then it will go out and it'll interact with the rest of the world and negotiate for me and maintain my privacy and security and so on. I think that's an intriguing possibility for the future. And you only get to change sort of the fundamental operating system every generation or so. We went from mainframes to PCs to smartphones, and this might be the next step.
Thanks so much. So we'll open questions to the people here.
Hi, Peter. My name is Jenny. Thanks so much for your talk. I also work at Khan Academy, so thanks for the shout out to Conmigo. I wanted to ask again about what you said about modeling students. I think we all know that humans are incredibly difficult to simulate, and in a teaching and learning context, there's the cognitive, the social, the emotional dimension. You mentioned your work in self-driving cars. I'm curious first, just intuitively, how you think about modeling students different from modeling cars. And then also, to really get to high quality simulations of learning and teaching, do you have hunches for the kinds of data we would collect or exactly what those simulations would unlock?
Yeah, it's a great question. I think we don't know yet, right? So I skipped over some of those slides because I wanted to get to the discussion period. So maybe I'll go back to them a little bit, right? So one of the slides I showed, there was a coffee cup or mug, and this is a standard problem that economists give to their students is they say, okay, you know, half of you are going to be given a mug, and then you're going to try to sell it to the other half of you students, and then we're going to record the price that it gets sold at. And there are sort of theories for how those markets should work out and what prices should be sold at. And depending on different students act different ways. What they showed in their paper was you could take a language model and tell it, you're a student and here's some attributes of you as a student. Now you're going to play this simulated game with the coffee cup and you're going to come to some agreement. And they found that that worked very well, that they could simulate that amount of being a student or being an actor in this economic game, and it sort of duplicated what the actual distribution was from real people. Now, that's a very small part, right? So understanding everything about a student of what they're interested in and what are they worried about, and do they have issues at home with their family, and are they hungry this morning, and so on. It's going to be tough to get all of that, but I think some of it at the level of, should our teaching sort of basically go in this direction or that direction? It feels like from what we've seen from these other simulations that we can get to that level. And I think it'll take a mix. So some of it will be done through simulation, but as we said, in order to get to that decent simulation, you've got to collect some of the right data to begin with. And so far, what do we have? Well, we've got a lot of click type data from the class I run, and at Con, you guys have a lot more of that, of interactions of here's what students did, and then subsequently, did they do a good job or not? So we've got some of that. I think you'd want to augment that with more detailed data at certain kinds, right? So, and there are privacy issues involved, but with the right permissions, it might be good to get a smaller cohort of students and be watching their facial expressions and the dilation of their pupils and so on to try to get a measure of their degree of attention and interest. And then it might be good to take a small portion of them and have in-depth interviews and sort of talk to them for an hour about their experience. So I think you want to gather data at all levels, right? Sort of this gross millions of clicks at a time, and then sort of this intermediate level of gathering more data and the very in-depth one-on-one personal interviews. And from that, you start to build a better model, and then you run the model and verify whether it works as well and continue to try to improve it.
So let's do one more question here.
Thank you. Thanks for your talk. I'm a PhD student in the School of Education, also HI fellow, so we interacted briefly 2 years ago. My question was about your starting point about care leads to learning, and I think that's great, but I think care is such a scarce resource. So as an instructor, as a TA, I think teaching is kind of my way of showing my care. Teaching is caring. And in my research of attachment, I think we see that secure relationship leads to free exploration. However, my question is when, whom, and how do we want to administer this care? So in the traditional classroom, it's really hard for teachers, especially in the current setting, to be caring for every single student in a personal level. I think for the children or even adults ourselves, it's sometimes really hard to care about things ourselves or know how to care for ourselves. And then for the parents, I think it's very lucky to have parents who have the energy and knowledge to care for you and kind of know what's going to happen in the future and kind of really support you there. So I think now people are exploring AI to be maybe a minister of care, but I feel there are a lot of potential risks there. And also how much do you maybe technically or maybe socially wanting to replicate that care, to what level? Thank you.
Great question. I think you've hit on really important issues. I guess one of the things is I certainly agree that having a personal interaction with a real person who cares about you is crucial to education and to well-being. I think to some extent you can form a bit of a personal connection with a computer, but it's always better with a person. But I think when you think of this as a partnership between the automated tools and the humans, it opens you up to more solutions, right? So you can think about more personal relationships with peers, right? So more time, right? So getting away from the idea of everybody's in the class sitting silently and listening to maybe they're talking to each other and forming relations and encouraging each other. That's part of it. And then also, if we have a machine that can take on some of the teaching duties, maybe we can choose our instructors more for care than for expertise, right? So, every faculty at Stanford is chosen because they did an outstanding PhD and had outstanding research and were one of the research leaders in their field. And any degree to which they have empathy and compassion is secondary to those requirements for expertise in their field. Maybe we could split some of that up to say, you're going to get some time with the computer, some time with an expert in the field, and some time with a mentor who's empathetic, but maybe is less expert in the field. So I think there's lots of opportunities to combine different sources to get to this goal. And I certainly agree with you that having that type of care is absolutely crucial to success.
Thanks so much, Pete, for these amazing insights, and really enjoy it. I also want to really shout out to both Michelle and Ben. So this, Peter, this is our first time doing Zooms, but I think we did it. Thank you all so much.
Yeah.
And next week, thanks,
My
Pete.
apologies again for being a little bit late, and thank you so much for accommodating me.
Pete, thank you so much for being here. So next week we'll have Rob Rich, and we'll talk about again, it's always about AI. So at Stanford, we'll have to talk about that. So if you have time, please join us next week, and we'll think about AI from other perspectives. Again, really appreciate all of your patience here. Thank you for being here today, and I hope you have amazing Tuesdays.
Thank you. Bye.
Record.